Take a strip of paper. Connect the ends. And you get a simple cylinder. It has two sides. An inside and an outside. It has two edges. Top and bottom. But now, take that same strip. Give it a half twist. And connect the ends. This is the Mobius strip. It is one of the most fascinating objects in mathematics. Why? Because it defies our intuition about space. The Mobius strip has only one side. If you were an ant walking along the strip, you could walk the entire length of it, traverse both the top and the bottom, and return to your starting point without ever crossing an edge. But there is a catch. When you returned, you would be upside down. This property is called non-orientability. In a non-orientable world, there is no consistent definition of left or right. In topology, the study of geometric properties preserved under deformation. The Mobius strip is a surface with a boundary, unlike a sphere or a torus, which are closed surfaces. The Mobius strip has an edge. In fact, it has only one edge. If you trace the boundary with your finger, you will traverse the entire perimeter and end up back where you started. Here is a classic puzzle. What happens if you cut a Mobius strip in half? Right down the center line. You might expect two separate rings. But mathematics surprises us. You get a single, longer loop that has two twists in it. It is no longer a Mobius strip, but a homeomorph of a cylinder. If you cut that loop down the middle again, you get two interlocking loops. This shape isn't just a mathematical curiosity. It has real engineering applications. Conveyor belts are sometimes built as Mobius strips, because the entire surface area helps to support the load. They wear down evenly and last twice as long. In electronics, a non-inductive resistor can be made by twisting the resistive wire into a Mobius shape, cancelling out its own magnetic field. From the architecture of graphene molecules to the study of complex knots in DNA strands, the Mobius strip appears in nature and technology alike. It teaches us that a simple twist in perspective can fundamentally change the nature of reality. Sometimes, to understand the whole picture, you just have to look at it from the other side, which, as it turns out, is the same side.